Okay, just going over a few problems. Again, not going over all the problems. The homework tonight was 2 through 22 from, if you're using the workbook pages, it was page 328 to 331. Now, after looking through them a little bit more, there's some proofs in there. You can skip the proofs. So all of number 14, go ahead and skip it. And then I'm going to go ahead and go over these problems. Now, I did already go over number 4 in class, but again, I want to make sure that I posted a video about it. I'm not going to go in the exact same order as these problems because some of them are easier, some of them are harder. So I'm going to do some of the easier ones first, and then I'm going to jump back and forth to some of the harder ones. So let's first go down to question 7 and 8. Really, this entire section 7 through 9 is pretty much just like the examples that were in the other video. So you have this triangle, which is a right triangle with the altitude drawn in, and they give you 2 parts. So if I was to label this using the names that we did before, this would be the altitude. We would have, I could call this part 1, part 2, and then this could be leg 1 and leg 2. Now, we still have this entire thing is the whole. And then for number 7, they're simply asking you for what is the altitude. All right, QA is the altitude. So using your formula for altitude, which was altitude equals the square root of part 1 times part 2, you're just plugging in. So part 1 was 2, part 2 was 8. So 2 times 8 is 16, which is 4. So QA is the length of 4. Now, we may have to use that in another problem, so I'm going to go ahead and label it on this diagram. That's 4. For the second question, PQ, so this is one of the legs. So now I'm using the formula for the leg. The leg is the geometric mean of the adjacent part to the leg and the whole. The adjacent part to this leg would be the one that's touching it, which is this one, part 1. So the 2 is the adjacent part. The whole is the whole hypotenuse. Again, when we talk about parts in the whole, we're always talking about the hypotenuse of the really big triangle there. So these are the 2 parts of the hypotenuse. This is the whole hypotenuse. Now, we're going to use that formula. So leg equals adjacent part times the whole. Again, the adjacent part was 2. The whole, well, you have to add those together. 2 and 8, that's 10. So this entire length is 10. So 2 times 10. So now you have the square root of 20, which if you want to simplify it as a radical, you can. That break down into 4 and 5. Square root of 4 is 2, so that's 2 radical 5. Or if you take square root of 20 and simplify it, or change it to a decimal, you can take square root of 20 on a calculator, and it'll give you 4.47. Again, I'm fine with you leaving it either way for now. Chapter 8, I'll be more strict about simplifying radicals. So on number 9, QR. For QR, that's the other leg. So now we're just plugging in pretty much the same thing we did up here. We're still using the same formula, but now we're looking for leg 2. So up here we just found leg 1. Now it's leg 2. So the adjacent part to leg 2 is part 2, which was 8. The whole is still 10. So now this is the square root of 80. So square root of 80, again, we could simplify that. 80 breaks down into 16 and 5. Square root of 16 is 4, so this is 4 radical 5. Or if we take the square root of 80 on a calculator, the decimal is 8.94. Alright, so 7 and 8, those are just like examples that we had yesterday. If we go back up here now to 4, 5, and 6, you can do these several different ways. So number 4 alone, you can use any of 3 different methods. So I'm going to call this piece X for the time being, and then I'm going to label these pieces the same way that I did on the other figure. This is our altitude. This is our, let's say this is part 1, part 2. So this would be leg 1 and leg 2. And then again, we also have the hole. Now, if this is going to be x, we are going to find that one of 3 ways. Easiest method is going to be using the altitude formula, because in here we already have the altitude. We already have one of the parts. We're just missing the other part. So you have 2 out of the 3 things that you need to use the altitude formula. So again, altitude formula was altitude equals square root of part 1 times part 2. Now, when we multiply these, well, again, we're plugging in first. 9 goes in for altitude. Part 1 was 27. And part 2 is x. So again, 27 times x, that's just 27x. We need to solve for x. So now it's algebra. Again, you have to use your algebra skills a lot in this semester because there's a lot of formulas that we're going to have. Now that we have this plugged into the formula, it's all algebra. We have to solve. We have to undo all these operations. I can't get rid of the 27 yet because it's trapped underneath this radical. I got to get rid of that radical first. So the first step in undoing this, so that we can get x by itself, is I have to multiply this side by itself, or squared. That's how you undo a square root. A square is the opposite of square root. So if I am squaring this side, I got to square the opposite side. So now we have 81 is equal to 27x. All that happened on this side was the radical and the square canceled each other out. So now, last step, divide both sides by 27. So if you divide by 27, x is 3. So ER is 3. Was that the only method? No. There's several methods you could use. This section doesn't go over Pythagorean theorem because Pythagorean theorem really happens in chapter 8, but we've done Pythagorean theorem about 5 times already this year. So on here, if you wanted to use Pythagorean theorem, you could have. However, it is going to require a little more algebra. So if we had set the same problem up, so I'm just going to do it over here, x squared plus 9 squared equals 3 radical 10 squared. This is a little right triangle. X and 9 are the 2 legs. The 3 radical 10 is the hypotenuse. So I have a squared plus b squared equals c squared. If we square these parts, we have x squared plus 21. When you square, again, using your algebra skills, both of these numbers that are being multiplied get that product. That's what we call the product rule. So on here, this is going to be getting the 2. So this is going to be 3 to the second power. This is going to be square root of 10 to the second power. Well, 3 to the second power is just 9. Square root of 10 to the second power is going to be 10. Because again, the square and the square root cancel each other out. Now these two are still being multiplied together because that's what signs in between this 3 and this 10. The multiplication symbol. So we have 9 times 10 is 90. This side we still have the same thing. Bring the 81 over by subtracting it. So you subtract 81 from 90, you end up with 9. Square root of that equals 3. Again, same exact answer as before. Now, you could also use the leg formula here. However, it's not a very good option because we don't have the whole. If you were to do the whole with the leg formula, you'd have to add these two together. Yes, you'd only have one variable, but then you'd have 27 plus x as the whole. You'd have x as the adjacent part of the leg, and you're going to end up with a quadratic equation. So unless you remember how to solve a quadratic equation, you probably don't want to use the leg formula on this one. Again, it still works if you remember how to solve a quadratic. Now, for 5, we're doing a different side, df. df is the one that I just labeled as leg 1. So, I'm going to use a different color for this one. We have leg 1, so we're going to have to use a leg formula because we can't use the altitude formula because altitude doesn't have any legs in it. So leg 1 equals do the square root of the adjacent part, which in this case would be part 1, and the whole. Again, I'm writing this equation specifically for leg 1 because this is the adjacent part and the whole. I wouldn't normally just write P1 here, but that's the adjacent part for this problem. So now, we have the leg. Again, we don't have a number for, that's what we're solving for. The adjacent part is 27. The whole, well, we solved for that piece just now. We know that this piece is 3. So if that piece is 3, the whole, 27 plus 3 is 30. So, I'm going to put 30 in here. So now we have 27 times 30. Well, 27 times 30, that gives us a pretty big number. That's 810. So we have the square root of 810. Now, if I square root 810, that's not going to give us a whole number again. So we simplify. Actually, let's simplify the radical first here. We can break this down into 81 times 10. Square root of 81 is 9, so 9 radical 10. Or, if you take the square root of 81 to 810, that'll give us a decimal of 28.46. Finally, DE. DE is the whole. So you can do this a couple different ways. I'd use the pieces that we already have given to us up here. So I would use this leg. I wouldn't use, well actually no, we don't even have to go that route because we know what the whole is. We already solved for it. DE, it's a combination of 27 and 3, which was 30. So we know what it is already. It's 30. We solved for it. Could we went back and set up a new proportion or set up a new formula? Yes, but we don't need to. We already have it. All right, so that was those 5 problems from this side. Now, I also wanted to do 2 other problems from another page. Again, 14 I said you can skip, so just skip over that one. 20 is a little more challenging. So we have 20A I want to do with you guys. We have an altitude, so we're definitely going to be using altitude on this problem, and we have the 2 parts. So what makes this problem challenging is the fact that when you plug this into your formula, let me go ahead and label it first. Altitude is the geometric mean of the 2 parts, so part 1, part 2. We have the altitude is 8. Part 1 and part 2, they both contain an m. This book does have some problems that are going to turn things into quadratics. This is a quadratic problem. So, first thing that we could do, I'm going to get rid of the radical so that we no longer have a radical. Square both sides. So this side will be 64. This side, again, the radical will be gone, but we can go ahead and distribute that 2m at the same time. Again, so there's 2 steps here. I went ahead and squared to get rid of the radical. And then I'm distributing so that I'm multiplying that 2m to each of those terms. So this gives us 2m squared and negative 8m. Now, there is more than one way to solve a quadratic equation. I'm going to go with one of the most basic methods, which is factoring. But in order to do factoring, we will have to do some simplifying here. So first, let's get this over to the other side so it's set equal to 0. So this is a little bit of a review on factoring because we have our quadratic equation in standard form set equal to 0. We have an a value that is greater than 1. So we're going to take that a value, and since everything here is factorable by 2, we can just go ahead and divide it off. if we divide it off from both sides, it kind of just goes away. So divide everything by 2, including 0. So that's still just 0. This is now m squared minus 4m plus 32. So now, there are 2 answers to this equation. Because when we have a quadratic, there's always 2 answers. We have to find factors of the last term that add to the middle. And factors of the last term that add to the middle. So 32. Let's see, we have 16 and 2. That doesn't work. We have 4 and 8. Alright, well, that middle term is negative. This term is positive. So in order for this to happen, we would have to have something's wrong. That can't happen. Hold on. Made a mistake somewhere. Oh, it's the 64. This should have been negative. I moved it across. We moved it across. We had to subtract it. So that's a negative 32. There we go. So we still have the same factors, but now, in order to have a negative 32, one of the 2 factors has to be negative. So here we have a negative in the middle. The bigger number is going to have to be negative. So we're using these 2 factors to split the middle term. So you could split this middle term and then factor by grouping. Or if you remember some of the shortcuts from Algebra 1, if your lead coefficient is 1, which we purposely made it 1 in this problem, these 2 factors that we just found that add to the middle are going to be our final 2 values in our factors. So we'd have m minus 8 as one factor, and m plus 4 as the other factor. Now, if I set both of these equal to 0 and solve, one of them gives us a negative number. One of them gives us a positive number. So let's see. If I plug in this one, m minus 8 equals 0, m is positive 8. If I do this one, m plus 4 equals 0, then m is negative 4. Well, if I plug negative 4 in here, I'd have a negative length. That doesn't work. So that one's out. There's only really one answer that works here. Anytime we do a distance problem, you have to have positive values for your lengths. So here, the only thing that works is an m value of 8. Now again, that's a much harder problem, requiring a lot more algebra skills. 21 just looks confusing, but it's actually a very simple problem. You have, I don't even know how many right triangles here, but you have a bunch. You have the overall right triangle, that's there already, plus you have this right triangle that's also split with an altitude. So really, I think they're just trying to confuse you, because they give you so much information on here, you don't need it all. To find W, an easy way to do that is, in the really big triangle, this is our altitude. So this is a leg. And if this is our leg, we can take the adjacent part and the whole, which in this case is 13, and plug them into our formula. So again, leg equals square root of adjacent part times the whole. The leg here is W, the adjacent part is 10, the whole is 13. So 10 times 13 is 130. We need the square root of 130, which square root of 130 is not a whole number. In fact, that can't even simplify, because the only factors that go into that are 13 and 10. And then 10 can break down into 2 and 5. None of those are perfect squares. So it can either stay like that as an exact value, or write it as a decimal, 11.4. Alright, those are all the ones I wanted to go over with you guys. Again, good luck on the rest of them. We have a quiz tomorrow. Make sure you study. For the quiz tomorrow, just looking back at some of the notes, you'll have information about geometric mean. You know that in order to find a geometric mean, you have to multiply two numbers together and square root them. You'll find a problem similar to this, where you have to identify the correct order here. So again, know that. And then you'll have 3 problems using your formulas from down here. So again, I said this is the most important part. That's going to be the majority of your quiz. You have 3 problems with that. So good luck on the quiz tomorrow.